So hello guys, today I'm going to share with you about my remediation process on how to remediate a contaminated soil. But first of all, let me explain a little bit about bioremediation. Bioremediation techniques are destruction techniques to stimulate the growth of microorganisms using the contaminants as a food and energy source. This technique have been successfully used to remediate soil and groundwater contaminated by petroleum hydrocarbons, solvents, pesticides, wood preservative, and other chemicals. Oxygen, water, and nutrients are added, and the temperature and pH are controlled. That's how the microorganisms do their job. And microorganisms can be adapted to degrade specific contaminants or enhance the process. So for the bioremediation method, it is actually there are two types of bioremediation, which is in situ and ex situ bioremediation. In situ bioremediation is in place treatment or in the contaminated site, where and ex situ bioremediation is the above ground treatment of contaminated soil or water that is removed from a contaminated site. So for the advantages of in situ bioremediation is we don't need to excavate and transport the soil as I informed before. In situ bioremediation is where we do the job at the contaminated site, so it is less expensive. We don't have to waste our energy to manage to take this contaminated soil into other place like that. And it also can treat a large volume of soil at once, because if we transfer the contaminated soil, we only get a small amount of contaminated soil. Yes, like that. And in situ bioremediation is the most effective if permeable sandy soil, which is uncompacted, which is if the contaminated soil is compact, it is very hard for the microorganism to bioremediate. Yes, and it will be slower to reach clean up goal, because if the degradable contaminant is less, it will require years to remediate the soil. So for the example of in situ bioremediation is biosparging, bioventing, and what else? I think that's two. So for the advantages of ex situ bioremediation, as we all know, ex situ it is not on the contaminated site, so the techniques can be faster, easier to control, and used to treat a wider range of contaminants and soil types than the in situ techniques. Why I say this? This is because as I informed before, ex situ techniques, we have to transfer the contaminated soil, some of the contaminated soil, to the project. So the contaminated soil is easier to control, as the amount of the soil is less, right? So but however, the ex situ techniques, they require the excavation of soil, so it will lead to more expensive. And I think for the equipment we have to need engineer to transfer to have methods of technology to transfer the soil like that. So the contaminated soil usually requires treatment before and sometime after the actual bioremediation step. This is because if we transfer the soil, we actually get more microorganisms during the transferation of the soil like that. So for the example of ex-situ bioremediation is biopiling, biofarming, and windrow composting. So for my method of bioremediation, I will choose windrow composting. This is because let me share you a little bit about windrow composting. Windrow composting is the production of compost by piling organic matter or biodegradable waste such as animal manure and crop residue in a long row, which is windrows. That's why we call windrows composting, because the waste is has been piled in a long row. Yeah, this method is suitable to producing large volumes of compost. Windrow composting process compost is a controlled biological process by which organic contaminants are converted by microorganisms under aerobic and anaerobic conditions to innocuous, stabilized byproduct. In most cases, this is achieved by the use of indigenous microorganisms. So, for the type of feedstock and nutrient balance for this composting method to occur. So for this windrows composting, it requires a proper balance of green organic materials and brown organic materials. What is the difference between these two? So green organic materials include grass clippings, food scraps, and manure, which contain large amount of nitrogen. Whereas brown organic materials includes dry leaves, wood chips, and branches, which contain large amount of carbon but little nitrogen. Obtaining the right amount of nutrient which mix together requires experimentation and patience. It is the part of the art and science of composting. So, next, for the particle size for this composting to occur, we have to do the grinding, chipping, and shredding materials to increase the surface area. Why we need to increase the surface area? Because it will help the microorganism to feed themselves, because it will the materials are small, which is in big surface area. Smaller particle can also produce a more homogeneous compost mixture and improve pile insulation to help maintain the optimum temperature. If the particles are too small, however, they might prevent air from flowing freely through the pile. So the moisture content. Microorganisms living in a compost pile need enough moisture to survive. Why? what element they need. So water is the key element. It helps transport the substances within the compost pile and makes the nutrient in organic material accessible to the microbes. Organic material contains some moisture in varying amounts, but moisture also might come in form of rainfall or unintentional or intentional watering. So, if the microorganisms want to live, they need the oxygen, right? So, for the oxygen flow, turning the pile, placing the pile on a series of pipes, or including bulking agents such as wood chips and shredded newspapers, all help aerate the pile. Aerating the pile allows decomposition to occur at a faster rate than anaerobic condition. For the temperature, microorganisms require a certain temperature range for its optimal activity. Certain temperatures promote rapid composting and destroy pathogens and weed seeds. Microbial activity can raise the temperature of the pile's core to at least 140 degrees Fahrenheit. If the temperature does not increase, anaerobic conditions will occur. For aerated or turn windrow composting, it is suited for large volume, such as that generated by entire communities and collected by local governments and high volume food processing business. For example, like restaurants, cafeterias, and baking plants. It will yield significant amounts of compost, which might require assistance to market the end product. Local governments may want to make the compost available to residents for a low or no cost. The type of composting involves forming organic waste into rows of long piles called windrow, like I just said before, and aerating them periodically by either manually or mechanically turning the piles. The ideal pile height is between 4 to 8 feet with the width of 14 to 16 feet. This size pile is large enough to generate enough heat and maintain temperatures. It is small enough to allow oxygen flow to the windrow's core. Large volume of diverse waste such as yard trimmings, grease, liquids, and animal byproduct such as fishy and poultry waste can be composted through this windrow composting method. So now I will share to all of you about my method of bioremediation, which is windrow composting. So this is my model. So this is my model, as you guys can see. You guys can see, right? So this is the windrow turner. It looks like a tractor like, right? So I will move this side first. So this is the feedstock that are piled in a long row, which is windrow. So this long row contains feedstock which has been shredded, mixed, and placed into the windrow along a non-permeable surface. And then the windrow turner, which is this is the windrow turners. It will turn on a regular basis to improve the oxygen content, distribute heat to regulate the temperature, and distribute moisture. This is the movement of the what do we call the windrow turner. So the windrow turner will repeatedly, as you guys can see, sorry. So the windrow turner will move in a long way, and then while it moves, there is actually a spiral here that will shred and mix the feedstock into small particle like that. If the movement is like this, it also provides the oxygen content and also distribute the heat, where the heat will flow from the tractor, from the windrow turner to this, yeah, and then it will go like this all the way. The last part of the process involves screening the compost to remove contaminants such as plastic and metals. Okay, so after the windrow turners have been repeatedly moved along this direction, the feedstock will be minced, right? It will be shredded, so we will see small or big particles that cannot be shredded. They will separate them. Then it can be removed and can be put back through the whole process until all of this have been composted down sufficiently. And in the end, the compost can be applied in a range of end users within gardens or brownfield sites, landscaping, and full-scale agriculture. Okay, so I will move my model aside. So, as all of the bioremediation method, it also have a limitation that we cannot further ado. So for the limitation for the windrow composting is that windrow composting requires large tract of land, as I showed it earlier. It will need a lot of space, so it will need a lot of space and a lot of money to buy the windrow turner, right? So, and it also need a lot of patience, because the compost cannot be done in one day. It may be several weeks, So in a warm, arid climate, windrows are sometimes covered or placed under a shelter to prevent water from evaporating. This will disturb the microorganisms to bioremediate the soil. Thus, it will take a longer period of time to make the compost. However, for the rainy seasons, the shape of the pile can be adjusted so that water runs off the top of the pile rather than being absorbed into the pile. If the water is if the water have so much, it will cause the microorganisms to not do the job nicely. So for my next point, windrow composting is a large-scale operation and might be subject to regulatory enforcement like zoning, and the compost should be tested in a laboratory for bacterial and heavy metal content. So I think that's all for me. Thank you for listening about my bioremediation method, which is windrow composting. Thank you for listening. Stay safe and goodbye.